So you've probably heard a ton about AI writing essays or making some pretty wild images. But what happens when you point it at the very edge of human knowledge? Well, today we're going to dig into the incredible story of how an AI might have made a genuine, brand new contribution to theoretical physics, pretty much all on its own. This whole thing kicks off with a theoretical physicist named Stephen Hsu. Now, Pete spent over a year really putting the most advanced AI models through their paces, trying to figure out if they could truly understand his very complex field. And what he found, well, it was something nobody saw coming. And this is the claim that sent some serious shockwaves through the physics community. The key phrase here is de novo. It's Latin, and it basically means from scratch. According to Hsu, the main idea for the paper wasn't just something the AI found and summarized, it was a completely new concept born inside the model itself. Okay, so that's the million-dollar question, right? I mean, we usually think of these models as super advanced pattern matchers, kind of like a fancy autocomplete. So how on earth can one make a genuine creative leap? Well, it turns out the answer isn't just about how smart the AI is, it's about how you work with it. Yeah, it really seems like most of us are just barely scratching the surface of what these models are capable of. There's a huge difference between how a normal person might ask an AI a question and the kind of structured approach you need for really high-level problem solving. Here's the key difference, and it's a big one. Most of us are one-shotting. We ask a question, we get an answer. But the advanced method is what's called a generator-verifier pipeline. Think of it less like a calculator and more like setting up a tiny AI research team, where one AI comes up with ideas and another one immediately tries to poke holes in them. And look, the results of this method speak for themselves. This is just mind-blowing. When you ask a top AI to solve problems from the International Math Olympiad, and these are some of the toughest math problems for high schoolers on the planet, the standard one-shot approach solves maybe 1 out of 6. But using that pipeline method, whoa, it jumps to 5 out of 6 solved. That is a massive, massive leap in capability. So how does this pipeline actually work? It's pretty cool. First, you have one AI instance that just generates a potential solution. Then a second AI acts like a super harsh critic, hunting for any bugs or logical mistakes. A third AI then takes that feedback and refines the idea. You just keep running that loop and it systematically filters out all that plausible-sounding nonsense that Hsu calls wild goose chases. Okay, so now that we get the method, let's get back to the story. Back to Stephen Hu and the exact moment this AI dropped a bombshell on him. All right, so picture this. Hsu is feeding the AI one of his own papers from about a decade ago. He's not even looking for a new theory. He's just, kicking the tires, seeing if it can understand his work as well as the human experts who reviewed it way back when. And what he found was it actually understood it better. And then, right in the middle of their highly technical chat, the AI just speaks up, completely unprompted. It offers to apply a specific concept from one corner of quantum field theory to the problem he was working on. It was a connection that came totally out of left field. And that was Hsu's reaction. I mean, this guy is a leading expert, and he was just floored. He had never, ever seen anybody make that specific connection before. But the AI, which has basically read every physics paper ever published, could just combinatorially link these two distant ideas in a way a human specialist might not. So, of course, who tells it? Okay, show me. And bam, the model instantly spits out a page and a half of equations. Who checks the math, and the equations aren't just correct, they're completely new. And those equations? They became the absolute core of a new peer-reviewed paper. This quote from Hu really puts it all into perspective. He's not claiming the AI is the next Einstein or anything. He's saying its contribution was on the level of a really, really good human collaborator, like a top-tier grad student or a colleague who just had a flash of brilliance. Now, as you can probably guess, the idea of an AI co-authoring a physics paper, well, it wasn't exactly met with a standing ovation from the entire scientific community. Yeah, when the paper was published, it kicked up a storm of debate and skepticism. Other prominent physicists were publicly questioning the work, questioning the AI's role. I mean, this is brand new territory, and it really challenges our fundamental ideas about where scientific discoveries even come from. So where are we at right now with this stuff? Well, the strengths are pretty obvious. You've got this incredible knowledge base to connect dots nobody else sees, and it can do complex math without ever making a mistake. But the weaknesses are a big deal too. It can send you down these time-wasting rabbit holes, and here's the kicker, it has a huge bias towards the current scientific consensus. That's a real problem when you're trying to find a true breakthrough. And all of this really points to a bigger shift. We're moving past the idea of AI as just a fancy calculator. We are absolutely entering the era of the AI apprentice. So Shu came up with this idea for a real Turing test for science. He argues the true sign of scientific intelligence isn't just knowing all the facts. It's knowing when the accepted facts are wrong. A real breakthrough often means going against what everyone else believes. And right now, these models, they failed that test because they're trained to reflect what we already think we know.
But here's the thing. Even with these limitations, the revolution is happening right now. A colleague of Hughes estimates that something like 70% of theoretical physicists under the age of 35 are already using these models heavily in their work. The next generation is not waiting around for permission.
So we've seen an AI perform like a brilliant apprentice, connecting ideas, doing flawless math. It's an undeniably powerful tool that is accelerating research. But it leaves us with this huge question. What will it take for it to evolve from an apprentice to a true peer, a true colleague, at the very frontiers of science?